Welcome back to the channel. The problem is to find the value of the following sum. Summation from k equals 1 to 506 of tangent squared of 2k minus 1 times pi divided by 2026. This problem might seem daunting at first, but with the right approach, it becomes manageable. To start solving this problem, we define theta as theta equals the fraction of 2k minus 1 times pi over 2026, where k ranges from 1 to 506. Next, if we multiply this theta by 1013, we get 1013 theta equals the fraction of 2k minus 1 times pi over 2. This means that 1013 theta is an odd multiple of pi over 2, which leads to cosine of 1013 theta equals 0. Now, using de Moivre's theorem, which states that cosine theta plus I times sine theta raised to the power n equals cosine of n theta plus I times sine of n theta, where n is an integer, we can proceed to expand and simplify our sum. Next, we expand the expression for cosine of 1013 theta using the binomial theorem. Recall that cosine of 1013 theta is the real part of cosine theta plus I times sine theta, raised to the power of 1013. This can be written as real part of the sum from k equals 0 to 1013th, the binomial coefficient. 1013th, choose k, times cosine theta to the power k, times I sine theta to the power of 1013th minus k. Now, separating the real terms, we get the following. At this stage, we can simplify our expression by factoring out cosine theta to the power 1013, which leaves us with cosine theta to the power 1013, multiplied by a polynomial in terms of tangent theta as follows. Since we know that cosine of 1013 theta equals 0 and cosine theta is not 0, this means the remaining polynomial in terms of tangent theta must itself be 0. Next, let u be tangent squared theta. This transforms our equation into a degree 506 polynomial in u, given by Vieta's formulas, the sum of all these tangent squared terms, which is the sum of the roots of this polynomial, is given by the negative of the ratio, which simplifies to 170,522. This is our final result. We can also compute the product of all these tangent squared terms. This entire product is equal to the product of all 506 roots of our polynomial in u, which by Vieta's formula is simply 1 over 1013. Now let's generalize this result for any prime number p. The key observation is that this sum can be written as summation from k equals 1 to a p minus 1 divided by 2 of tangent squared of 2k minus 1 times pi divided by p equals 1/3 times p minus 1, choose 2. Let's see how this formula works for small primes. If you enjoyed this mathematical journey, don't forget to like, subscribe, and share for more interesting math videos. See you next time.